Dear students, today we will discuss spherical mirrors. Already we have discussed plane mirror. This is plane surface and this one is curved surface. If it is a part of a sphere, then it is called spherical. Here we will make it mirror. It will be spherical mirror. So now this is a sphere. Sphere means football, volleyball, basketball, all spherical. So here we'll take a glass sphere of glass, then we cut a portion. Then this portion will be called spherical mirror. So in case of mirror, one surface is painted, colored, some chemicals are applied, and another part is the reflecting part. So here, if we want to make this is reflecting part, then here will be some chemicals painted so that there will not be reflection but reflection. So if you use this inner portion of the sphere, then this will be called concave mirror. So here this is outside portion, this one is colored painted. uh, so this is this part, interior portion is the reflecting surface, so it is called concave mirror. Now if this one, if you want to make this side is reflecting surface, means light will fall on this surface and will go back, means there will be reflection, and this part is painted, then that type of mirror will be called convex mirror. So this one is concave mirror. This part is reflecting surface. This part means from here up to here. Then in case of convex, this is the reflecting surface. Reflection will take place in this part, and this one is colored. No, there will not be reflection. So this portion is there. Uh, some chemicals are applied so that we can get reflection. So these are two types of mirror. One is convex mirror and one is concave mirror. Now, since this mirror is a part of a sphere, there is a center, and center to the surface, this distance is called radius, and this one is center, say C. So this center is the center of the spherical mirror, whether it is concave or convex. So in case of sphere, we call center and radius. In case of the mirror, we call center of curvature. Here also C is center of curvature. If you complete this one, then this will be the center. You will get a complete sphere. Then this is the center. So here we will call center of curvature, and radius from center to the curve up to here. This distance is called radius in case of sphere, and here we will call it radius of curvature. So we use the word curvature, center of curvature and radius of curvature. So another important point is this P. This is the point P. P is called the pole. It is the center of the mirror. From here up to here, this is the mirror. If this one is 5 centimeter, then from here also it is 5 centimeter. This is the pole. So this pole is the very important point, because all the distances will be measured from the pole. In case of coordinate geometry, we measure from the origin, and in case of spherical mirror, we will measure all the distances from the point P. So this P is called the pole. Let us see the definition. What is the pole? The center of the reflecting surface. So this is the reflecting surface from here up to here, and this center, this point is called the pole. Don't be confused with this center. This is called center of the sphere, and pole is the center of the reflecting surface. Then let me clear first. So P finished, C finished. Now the most important point is F. This is called principal focus. Now before that you should know principal axis. So this is the center and this is the pole. If you join the center and the pole by a straight line, then that straight line is called the principal axis. That means the straight line which passes through the center of curvature and the pole is called the principal axis. So this is the principal axis here in case of concave, and this is the principal axis in case of convex. Now the most important concept is focus. So let us consider a ray of light parallel to the principal axis. This is the principal axis and this is the ray. After refraction, it will pass through a particular point of the principal axis, and this particular point is called the focus or principal focus. Now this is the point of intersection of the principal axis and the reflected ray. This is reflected ray, and this definition is for concave mirror. In case of convex, it is somewhat different. Now see, here is the ray parallel to the principal axis. After refraction, it cannot come this way because already painted. This will go this way to the same medium. So in reality, the reflected ray and the principal axis will not meet. But if you extend it behind the mirror, then it will appear to intersect at F. So in case of convex mirror, this is not the real point, this is partial point. It will not really intersect, but it will appear to us that F is the point of intersection of the reflected ray and the principal axis. So let us see the definition what is written here. Principal focus is a point on the principal axis of a spherical mirror where a parallel beam, I have considered only one ray, of light after reflection either actually meet. In case of concave mirror, it meets, and in case of concave, appears to meet in case of convex mirror. So if you are here, this ray enters your eyes. For you, it will appear that rays are coming from this point F, not here, not from here. So this is the virtual point. It will appear to us that this ray is coming from the point F. We can consider so many rays, but if it is parallel, it will always appear to us that the rays are coming from the point F. But here it will not appear. It will really, if you are here, this the real ray entering your eyes. If you consider another parallel ray, then this will also pass through the point F this way. Because of mouse this appears to be curved, but this should be straight line. So this is the focus. In case of concave mirror, focus is in front of the mirror, and in case of the convex mirror, it is behind. This is the front side because reflecting surface, this is behind. And next one is linear aperture, diameter of the reflecting surface. So what is the reflecting surface? This one is the reflecting surface. This distance is called the linear aperture, and in this case also from here up to here this distance is called a linear aperture. The diameter of a spherical mirror, don't be confused, the diameter of the sphere mirror, the reflecting surface, the diameter of the spherical mirror is called a linear aperture of the spherical mirror. So thank you for watching.